Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about what are the various questions that may arise in the concept of missing data. So the very first question is that how to deal with the missing data. So in statistics, missing data or missing values may occur. So whenever no data value is going to be stored for the variable in an observation. So actually this kind of situations mostly occur as a result of manual data entry procedures and then equipment errors and incorrect measurements, right? So in statistics, there may be a chance of missing data or missing values may occur. So there may be a chance of entering no data. Sometimes it is missing or while taking the observations, or sometimes there may be the situations where the result of manual data entry procedures and then equipment errors and incorrect measurements. So these are some of the ways to find that missing data can occur. So next one is that what are the problems you are going to face with the missing data is the next one. So due to this, the problems what we are going to get is loss of efficiency and then complications in handling and analyzing the data and then bias resulting from differences between the missing data and complete data. So these kind of problems we can able to get with the loss of efficiency and then the complications in handling and then analyzing the data and the differences between the missing and then complete data. So next one is that how to deal with this missing data. So for this, missing data can able to reduce the representativeness of the sample and can then occur distort inferences about the population. So there is no need to use such a special method for dealing with missing values. So the method that is going to be used for data analysis has its own the policy for handling the missing values. So the deletion rule extraction methods may be considered attributes. So with missing data as irrelevant, and then the association rules extraction methods also going to be used may ignore the rules with the missing values. So normally what we can able to call it as conservative approach, and then handle the missing values as they are going to supporting the rule that is should be called as an optimistic approach. So in order to deal with the missing data, some of the methods that are available normally that should be decision rule extraction methods, and then association rule extraction methods, and then handling missing values as they're supporting the rule what we call it as a optimistic approach. So then there's another way of reducing this missing data, that is the reducing the data set here. The simplest solution for the missing data is that imputation problem here. So it should be one kind of method which could be the reduction of the data set and then elimination of all the missing values. So this can be done by elimination of sampling rows with the missing values or elimination of attributes with the missing values, right? So the simplest solution for missing data is that the imputation problem is the reduction of the data set and then the elimination of all the missing values. So this can be done by simply eliminating the rows with the missing values or elimination of the attributes with the missing values. Then treating the missing attribute values as the special values. So for this, what we have to do is this method is going to be deal with the unknown attribute values using a totally different approach. And rather than trying this to find some known attribute as its value, so what we have to do is, so we can able to treat this missing value itself as a new value for the attributes that containing the missing values and treat it in the some way of as other values. And next one is that replacing the missing value with the mean. So this is the method where you can able to replace each missing value with the mean of the attribute, and the mean is going to be calculated based on all known values of the attribute. This method is usually useful for numeric attributes and usually combined with the replacing the missing values with the most common attribute value for the symbolic attributes, right? So the replacing with the missing value with the mean value. So something some methods may arising. So what we are going to do this is, so what is where applications where the missing value is there, so that value is going to be replaced with the mean values, and replacing the missing value with the mean of for the given class. So this is another kind of method. So it should be similar to the previous one, but here the difference is that, so the mean is not going to be calculated from all the known values of the attribute, but the attribute values belong to the given class are going to be used. So previous thing is also same, where the missing values are going to be replaced with the mean values. See, this method also looks like too similar, but what we have to do is the missing value is going to be replaced with the value that belongs to the class, some same interval, the value is what we're having, so with that value are going to be replaced. And next one is that replace missing value with most common attribute value is another method here. So here what you have to do is, so where the missing value is done, that value is going to be replaced with the value that is occurred most number of times. So that should be this method will be follows here. So in this case, what will happen is the missing data for the given attribute is going to be replaced by the median of all known values of that attribute in the class where the instant with the missing value belongs. So right, so the another kind of the method here. Next one is that closest fit algorithm is another kind of method. So where this method also be used for dealing with the missing data. So this one is going to be used for missing the attribute values based on replacing the missing attribute value with the existing value of the same attribute from the other case. So which can able to resembles as much as possible with the case of that mean attribute values. Right, so the closest fit is also another kind of method. So where the value that is missed here, that should be replaced with the existing value of the same attribute here from another set. And next question is that explain different forms of missing data. So just now I said what are the different ways of dealing missing data. Now what are the different forms of the missing data is the question. So normally this missing data will be of different types, like unit non-responsive missing data, and then missing data at different cases, item non-responsive, and unobserved variable like this. So these are some of the different forms of the missing data. Normally, dealing with the missing data has been going to be a great challenge in data analysis context. So here, what you have to do is you have to need methods in missing the data analysis, so that minimize the bias and maximize the use of available information and getting the good estimates of uncertainty. So by using this, what are the methods we are using? So all the time these methods will able to process the minimize the bias, maximize the available information, and good estimates of uncertainty. So next one, what is unit non-responsive and item non-responsive? So unit non-responsive in the sense, suppose the data is missing an entire row, then can able to call it as a unit non-responsive missing data. Then item non-responsive means where the some missing data can occur along with the column wise. So here the data is missing in Q1, and here the data is missing in Q2, and here the data is missing in Q3. So this one you can able to call the item non-responsive missing data. So unit non-responsive means where the entire item data is missing, that entire thing we can able to call it as a unit non-responsive missing data. And item responsive means some data is missing some particular portions of that application, then it can able to treat it as item non-responsive missing data. Some of the unit non-responsive examples will be the person who is not in home, and then the person who does not pick up the phone, and then the person who hangs up on you, and rat that dies before the study, and then the country you could not get on you could not get on. So that something extra. So these are some of the examples of this unit non-response to missing data. So the person who is not at home, suppose I want to get the details of the application at the time, what will happen if the person is not there at that home? So this is one of the application of that. And the person who does not pick up the phone, right? Suppose, and then the person who hangs up on you and advertised before the study, the country could not get it on like this. Item non-responsive, that means I don't know, and then refuses to respond, left questions, left blank, and then failed measurement. So these are some of the examples where item is not responsive. Then how we're going to minimize the unit non-responsive missing data. So for this, what I have to do is call back if not at home, and then refusal, conversion, and then don't mess up. Clear and understandable questionnaire you have to be given. Clear and understandable questionnaire have to be given, and then polite request, and then incentives like this. So these are some of the ways of minimizing this unit non-responsive missing data. Minimizing item non-responsive in the sense, so here the well-written questions, and then minimize the misunderstandings and cross-culture example, and then standardized versus non-standardized, and minimize the skipping patterns, and then use some descendant measurement instruments and know what you are doing. So these are some of the ways of minimizing item non-responsive. And next question is that what are the different patterns of the missing data is another question that may arise. So for that, different patterns of missing data will be MCR, what we can able to call that should be missing completely at random. So here the values in the dataset can be missed completely at random. That means if the events that lead to any particular data item missing are going to be independent of both observable variables and of unobservable parameters of interest. So that occur entirely at random. That should be the missing completely at random case. So the values what is there in the data set, there may be a chance of missing completely at random. That means that, so if the events that may lead to any particular data item is missing, so independent of both observable variables and then unobservable parameters. So at that time we can able to treat it as a missing completely at random. And another thing is that missing at random. So here this is a quite alternative approach. So where it occurs when the missingness is related to a particular variable, but it is not related to the value of the variable that has a missing data. At that time, you can able to call it as missing at random, right? So previous thing is missing completely at random. So and missing at random is quietly opposite to the top one. So it occurs normally whenever the missingness is related to the particular variable, but it is not related to the value of the variable that has been missing data. Example, this is accidentally omitting an answer to a questionnaire. And another case is that missing not at random is the thing. So here, this is the data that is for missing for specific reason. So here, the value of the variable that is missing is related to the reason to its it is missing, right? So the value of the variable that is missing is related to the reason that is missing. So example of this is that if the certain question on questionnaire tend to be skipped deliberately by participant with certain characteristics. So at that time, you can able to call it as missing not at random case. Right? So this is the data. So that is for missing for a specific reason purpose only. So that is the value of the variable that is missing is related to the reason it is missing. That should be able to call that missing not at random. So what are some of the assumptions? So what we are going to make according to this missing completely at random, missing at random, or not completely at random. So for this, so when values are missing completely at random, so the probability of the missingness is unrelated to the value of the any variable, right? So when the values are missing completely at random, so the probability of missingness is unrelated to the values of any variable. So missing at random means if the missingness is unrelated to the value that is missing, but is related to the values of other variables. So right, so that should be missing at random. If the missingness is unrelated to the value that is missing, but it is related to values of other variables. Example, the question about the typical number of hours spent browsing the internet might missing more often for married than the unmarried participants, right? So, but among the married subset, the missing is completely random, not related to how many hours the person browses. So, there's the example of this missing at random. Missing not at random is the case. So, if the missingness is related to the value that is missing here and often to the values of other variables as well. So, the missing values are more prevalent among those who completely browse more than among those who browse less. So this is the one of the case of missing not at random. Okay, missing not at random is the case which should be related to the value that is missing and often to the values of other variables as well. So next one is that explain different categories of handling missing data at the analysis stage. So this is the other question that may come here. So some of the methods that are available for handling the missing data. First one is that deletion method. So deleting the cases or variables that are missing. So example, some of the methods is list-wise deletion, pairwise deletion, and variable deletion. Imputation methods. So some of the substitution methods like single imputation and double imputation. So in single imputation, some of the techniques that may come here is mean imputation, conditional mean imputation, case mean imputation, regression imputation, last observation carried imputation, worst case, best case, and EM imputation. So these are the some of the imputation or what we can able to call it as substitution methods. So the methods that are handling missing data will be of different types: deletion methods, imputation methods. And some of the deletion methods will be list-wise deletion, pairwise deletion, and variable deletion. Imputation or substitution methods, it's like some of single imputation and double imputation. In single imputation means mean imputation, conditional mean imputation, case mean imputation, regression imputation, last observation carried forward, worst case imputation, worst case, and EM imputation. So let's see one by one. So very first thing is the list-wise deletion. So in list-wise deletion, this is one of the good method when the proportion of missing data is less than 15%. And then advantages with this method is that so it can be used for any type of statistical analysis and no special computations are required and parameter estimations are unbiased. Standard errors are appropriate compared to the original data. And disadvantages, it may remove as a considerable fraction of the data is the disadvantage of this method. So list-wise deletion is the good method, very good method. But whenever the missing data proportion is less than 50% only, and the advantage is that it can be used for any type of statistical analysis and no special computations are required and the parameter estimations are unbiased and standard errors are appropriate compared to the original data. And disadvantage is that only consider for fraction of the data is going to be removed here. Suppose take an example on right side. So here I am having the data like subject, age, gender, and income. So here the data is missing here, and for the subject 4 the gender is missing, and for subject 8 age is missing, and for subject 3 income is missing. So what I have to do according to this method, I have simply deleting the rows where the data is going to be missed. So that is the one of this method here. And next one is that pairwise deletion. In pairwise deletion, involves dropping cases with the missing values based on analysis by analysis. So advantages, so using all available non-missing data, and disadvantage is that standard errors are going to be estimated and then statistics are to be biased. So these are the disadvantages of this method here. So according to pairwise deletion method, so the pairwise deletion involves the dropping of the cases with the missing values based on analysis by analysis, and then advantage is that we have to be use all the available non-missing data, and disadvantage is that the standard errors and test statistics are going to be estimated. That is the disadvantage here. So take an example here, same thing, subject age, gender, income I am taking. So if I'm going to take this, so the missing data for subject 3 missing data comes in income, and subject 4 missing gender is missing, and subject 8 age is missing. So for these three, what you have to do is you have to take analysis. So which one is going to be deleted? So whether I have to delete this third subject, or I have to delete fourth subject, or I have to delete eighth subject. So how to analysis? So whether age is income or not, whether gender is important or income is important. If I consider age, so age is important, and then income if I take, so income is also important, but gender, so gender is not that much important when compared to the age and the income. So what I have to do? The data that is missing in gender part is going to be deleted. So that is the pairwise deletion method. Variable deletion. So variable deletion means, so it involves the dropping the variables with the missing values on case by case basis. Okay, so the advantage is that makes sense when a lot of missing values in a variable, and if the variable is of relatively less importance, then disadvantage is that the loss of information regarding that variable. So in variable deletion, here also the dropping of variables itself with the missing values and case by case basis. Previous thing is analysis to analysis base. So here it is case to case basis. So the advantage is that, so when a lot of missing values in a variable is going to be identified, is relatively less importance. So that becomes the advantage, and disadvantage is that some of the loss of information regarding the variable is missing, that should become the disadvantage. So same thing I'm taking, so subject A, gender, income. So subject 3 income is missing, for subject 4 gender is missing, and so for subject 8 age is missing. So what I have to do is, so which variable is having less importance when compared to the other variables? So age, gender and income, right? So the gender is having less importance when compared to age and income. So that's why what I have to do, I have to delete this entire variable according to this method. As the name suggests, variable deletion. So this variable I'm going to be deleted. And next one is that mean imputation. So mean imputation is another method which is going to be replace the missing values with the mean of the variable. Okay. So take it out. So here the data is missing in variable 1, and in variable 3 I'm going to, here the data is missing. So how I'm going to fill this missing value with the mean imputation method? So for that, what I have to do, I have to consider the mean of that variable. So if I'm going to take, so what is the mean of this variable? I have to find it out. So let it be 7.44 is the mean. So this value I'm going to fill with the missing value. Similarly, I'm going to calculate the mean of entire thing. Suppose I'm going to get as 8. So the mean of variable 3 equal to 8 point something 23, and this thing I'm going to fill with the missing value that occurs in variable 3. And next one is the conditional mean imputation. So based on some conditions, I have to fill the or replace the missing values with the variable mean. So example, so here the data is missing, and here also data is missing, and here also data is missing. So how can I able to fill with this value with the conditional mean imputation? So I can able to write some conditions. If the mean is greater than 9, so replace with 10.20, and then if the mean is less than 8, replace with 8 8.25, and then mean is less than 7, here also less than, and if it is 7.29, like this I can able to write some conditional means. So then I have to fill according to the value what I'm getting with the missing value. So here also I can able to fill with the conditional mean, and here also I can able to fill with the missing value with the conditional mean. And next one is the case mean imputation. So case mean imputation means here the missing values are going to be replaced with the information for other variables from case to case to impute the missing value, right? So the case mean imputation means, so where the data is missing here, that should be replace the value with the case mean. So I can able to write some of the cases. So based on this case, I can able to fill the missing values. The next one is that regression imputation. So regression imputation means here the missing values are going to be replaced with the values of missing data based on the regression equations for the cases with the non-missing values. So here data is missing in variable 1, and variable 3 data is missing. So I can able to fill this missing value according to the regression imputation. So for that I have to define some one formula here. So the variable 1 is equal to 4.6 minus 7.34 into variable 2 plus 1.139 into variable 3. So like this I creating some regression equations. So I have to substitute these values. What is the variable 2 and then variable 3 here. So I can able to substitute this value, then I can able to get 6.3 as the value. That value is going to be filled with the missing value. Similarly here also I can able to fill with variable 3, then how to fill with find out variable 3 here. Variable 3 is equal to, so 1.1 sorry 1.139 into variable 3 is equal to variable 1 minus 4.621, then product of this. Like this I find out the variable 3 and substitute the values of variable 1 and 2, and then I can able to get the missing value. And next one is that last observation carried forward. So here so where the data is missing here, that one should be find it out. According to this method, it imputes the missing value as a value on the same outcome the most recent time it was observed. So that should be variance, or I can able to take the average of T1 and then T2. Okay, suppose either this missing data is missing, so what I have to do, I have to take the average of this and I have to fill with this missing value. Similarly here the data is missing, so I have to take the average of this or variance of this, I can able to consider it, and I can able to fill with the value with the missing value. So last observation carried forward, that one means I can able to take the average of other variables what is predicted. Interpolation. So interpolation also another kind of method where you can able to fill the missing values with the interpolation, and it is also going to be useful for the longitudinal data sets. And worst case and best case imputation. So here the worst case imputation means where you can able to replace the value with the worst case scenario for categorical outcome, and similarly the best case replace the missing value with the best case scenario for the categorical outcome. So these are some of the best case and worst case imputation methods. Then expectation, that should be maximization or minimization. So according to this method, the missing value that is missed is going to be replaced with the ML imputation. So in each step, what we are going to do is that is the expectation method. The expected values are going to be calculated based on all the complete data points. And in M step, that should be maximization, The procedure imputes the expected values from the each step and then maximize the likelihood function to obtain the new parameter estimates. Right. So these are the some of the expectation maximization method. So in expectation method, all the expected values are going to be calculated based on complete data points, and M step the procedure going to be some procedure are going to be adopted, and that according to that procedure we are going to be fill the missing value with the expected value, and then we have to be maximize the likelihood function to obtain the new parameter estimates. And multiple imputation is another kind of method. So here what I'm going to do is, so in multiple imputation it is quickly become the gold standard approach to handle the missing data, and computationally it should be a complex one, right? So in multiple imputation, so the multiple imputation is under one of the method that is going to be quickly become very gold standard approach, but computationally it looks very complex one. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.